Hello, I'm Mohan Jayaraman, technologist at Softura. Softura has been in business for close to 25 years, done many machine-to-machine integration and analytics type of work, much before the term IoT was coined. So I'm here today to talk about one of the case study recent work which we have been doing with them, and we are continuing to do on some innovation work with a major construction equipment manufacturer, OEM. Close to 250,000 equipment assets that they have on field globally. And some of these assets we are talking about are several $100,000 worth, right? So obviously when they approached us, Softura, to solve their business problem, there are a few, right? First and foremost, the asset cannot simply go down. The uptime has to be maximized or achieve the zero downtime capability. And that comes with obviously knowing more about the device proactively sometimes acting based on certain rules. So enhancing the customer satisfaction. Not a very crowded space. There are a few other competitors for this customer, and ensuring that the customer is not really moving away, having the sticky relationship with them is very important for them. The second thing was, of course, increase the product quality, drive operational efficiency, reduce the recall, get enough insights to the quality team in advance so that they can plan their product cycle was one of the critical factors of this IoT journey. The other goals were obviously increase the brand value in terms of staying in the innovation space, in the digital space, to be a differentiator, to wean away some of the other fleet owners from going to the other, their competitors. One of the interesting other goal of this IoT was from a traditional, usually you have this new products and services and operational efficiency, was how do we increase the genuine use of the genuine parts of their system. So obviously that came with, enough about the machine, you're going to be able to give real-time insights to their warehouse so that they can stock the parts just in time, right? The other aspect is telling the customer not that there is just a problem, but also giving them enough lead, and when they walk into the dealer place or the distributor, they have the right parts in time, and then the customer satisfaction is satisfied. So it was end-to-end system to solve these business problems, and what we developed was actually a solution which brought three parties or three entities together. First is the OEM, the manufacturer, and then the distributors were the biggest users of this, and the third is your actual fleet company or the fleet owner, fleet managers, the end customer of this whole construction equipment manufacturer. So the system had these key functions. One, the telemetry database. I think in the first presentation we heard about the preventive maintenance and predictive maintenance. We had a similar approach here. One, the preventive maintenance primarily driven off of what they call SMR hours, right? The service meter reading. How many hours that particular machine has been in the execution or operation, and there are certain rules based on certain make model of this particular equipment. If it has been running for certain hours, you have to go through certain preventive maintenance. The predictive maintenance is where the telemetry database or a condition-based model and the data-driven model-based work which we have done. I'll walk you through some of the solution aspect of it. The other key feature were asset tracking. Pretty standard, geo-based, latitude, longitude, geofencing. When the equipment enters the customer job site, the fleet manager was interested to get the notification. When it goes outside of this, because these are all very expensive equipment. If you rent once, you're spending several thousands of dollars, and there were cases where it was used for a non-job site as well. For in terms of controlling that, geofencing was one of the key use cases we had to develop. The other aspect was how the product is being used. It's great to know the health of the asset, but also if an operator is sitting and eating a sandwich, leaving the equipment on for 30 minutes, we are talking about like a $2,000 sandwich, right? $2,000 sandwich you just ate. So it's extremely important to not just look at the health of the equipment, but also how it's been driven, what conditions. We talked about the terrain, right? So once you mash up the the geo data, you get a lot of insights as to how they are driving this whole equipment, where they are driving it to. All this insights, data, it's all great, but the key thing is we are talking about, like I said, three different parties: distributors, the end customers, the fleet owners, and the employees and the OEM employees itself. We had to surface this data. Like I said, innovation was one of the key things. They had to stay one step ahead of their competitors, and bot is, everybody does a bot today, right? So one of the things was to surface this data in every possible channel that you could normally interact with. Going and pulling a dashboard is great, but also being able to ask a natural question in a bot, or being able to interact with your Alexa or your Cortana and whatever other channels possible to pull this data up. One of the other work which is still work in progress is the computer vision based parts identification in a warehouse, being able to use some augmented reality to identify a part and then get some additional data surfaced on top of it is something we are working on. It's not fully in production yet. So the solution, what does it comprise of? Microsoft Azure cloud-based platform as a service solution is what we built. These equipment had two connectivity mechanisms. Some were cellular largely, and in some cases where they are in a very limited or a constrained network capacity, they had a satellite carrier. They use satellite carrier to push this data to the cloud. Data was ingested through the IoT hub, Azure IoT hub, to stream this data through MQTT protocol. And from an ingestion standpoint, we had used Microsoft Azure Event Hub to partition the data by make, by model, so that you don't need to clog, and you can have a different quality of service for different customers or different fleet managers. Cosmos DBs, we started with SQL Server. Very soon, we heard in the first presentation, you learn it starts going huge. Then we moved to Cosmos DB as the product was released. Infinitely scalable, global support, and you're able to operate it with peace. Stream analytics we are using in a limited fashion for the preventive maintenance. When the stream of data comes in, you look for certain characteristics and attributes, and you apply on them as the stream of data comes in, raise an alerts, and integrate with the system. Azure Function is one of the best thing I would say we have ever used in this project. In terms of the capability, the programming language support, and the cost of actual consumption, what you're paying, the cloud consumption, it's phenomenal. I'll talk about it briefly later. The integration channels, everything is through API, and then bots to surface up in some cases, and largely notifications through SMS and email, and dashboards to pull up the reports. From the predictive maintenance standpoint, we have used Microsoft ML Studio, where you can bring in this data and additional contextual data from the other ERP system, the quality systems, to create the machine learning models. We have done 2 models so far, primarily on remaining useful life of certain key components and the parts which they wanted us to look into, and that's in place. So some of the interface of the application, I'm sharing it with this is a geo-based solution to track your asset as it happens. The second interface, this is actually a combination of 2 things. One is the cautions. So some of the analytics is actually performed right within the equipment itself. So the equipment tells you I'm sick, right? That's pre-programmed. It's a firmware edge-based analytics. In largely, the data stream is pushed to the cloud, and then in the cloud we run a bunch of algorithms and bunch of rules as a stream of data comes in. So what you're seeing here in the screen is a combination of abnormalities which we detect at the cloud, and some cautions which is detected right at the edge itself. So bot, we could have done a very simple way, program it for Alexa, program it for Cortana, program it using your bot framework, which every technology company provides. But what we did at Softura was to create a framework. Probably I would say I haven't seen anybody else take this approach, which is instead of training your machine learning model at every layer, For Cortana, you go to use, let's say, a language understanding intelligence service. And then for Alexa, you log into Alexa skill, you train your model, create your utterances, map your entities and so on. Instead of doing at every channel possible, we wanted to do it once, right? So all the possible utterances, all the possible, the model training, NLP training, we wanted to do in single place. So we pushed it to bot framework, obviously, because we were using Microsoft stack for this engagement. So entire training is done in Louis model, and then the bot framework is where you're integrating with your enterprise. That's where you're pulling in data. So if I'm asking a question about what's my fuel level, it's actually trained in the Louis model running on Microsoft Azure cloud. But the channel where you're asking could be in Alexa, right? Alexa is just going to be passing through. It doesn't go through AWS at all. It just routes it all the way through your Microsoft stack. So this is the framework of the bot which we had developed, and to surface the insights and the telemetry data aggregation and so on. Some interfaces from what we have done for bot. This is a screenshot where you're asking a question of, how can you help me? You're starting with the basic conversation of, hey bot, how can you help me, right? To asking a specific question saying, for my fleet, what is the distribution of the equipment operation? How much of my equipment is operated on a power mode versus a economy mode, right? Asking a specific question and having your data rendered within your bot, and asking a question like, what are my top idling machines, right? In a very natural way. And this is actually another interface to Alexa. You're asking, hey Alexa, ask Softura what's the average fuel consumption for my fleet last month.
Sure. Your WA608 loaders consume 2,927 gallons. Your PC24011 excavators consumed 461 gallons. And your HM300 trucks consumed around 862 gallons.
So, in a nutshell, instead of looking through a prism of just a solution for the field, or just I'm doing an asset tracking for a fleet solution, or just looking at predictive maintenance, it's important to see the whole big picture, right? The whole end-to-end life cycle. It really starts with your plant operations, right? Any insights you're getting from here, you have to have a mechanism to feed the data back. It's end of the day, it's like any control system, right? You have to have a closed loop to push this data back to your plant, and also push it to the engineering and the validation team, because they can enhance your digital twin to validate it better so that they can stay ahead of the curve. And giving these early leads, if you have a predictive maintenance, give an early lead to the distributor so that they have the right parts in time when you go in, and they don't need to stock up the whole inventory and so on. So what are the key lessons learned or best practices, I would say, as a summary? One, we use cloud platform as a service largely, right? Except for 2 servers which we had to deal with for some legacy components which can't run on a PaaS component. Everything else was running with the platform as a service. So what does it really mean? The time to market was really fast because we didn't have to. It comes with a rich feature set, global support, and scalability. We didn't have to worry about it. As the data stream comes in, you just crank up and you're good to go. The second one was the serverless architecture, which I talked about. We didn't have to deal with the IP address. We didn't have to deal with the networking. We didn't have to. Auto scaling was built in, right? So you write as Azure as a function, it's literally function as a service. Moving from a SaaS to a FaaS, function as a service, it can just scale as you build. And guess what? You're being charged only for the time that function gets executed. If you're running a research project with 250 vehicles, running for a period of 2 months, if the function gets called only X number of times, you're getting paid only for the CPU time and some data egress and egress, but that's about it, right? As opposed to having a server standing 24/7, nighttime nobody uses, you're still paying for it. The NLP utterances, I already elaborated quite a bit about having a single way to train your machine learning model, and then have every channel route through it, instead of programming for Alexa, programming for Cortana, programming for Google Home and Siri and whatnot. Last but not the least, have a data lake approach, or at least have a mechanism where there is a hub and a spoke model where this data is cascaded to other systems which are interested to pull this and then perform operation, whether it is a warehouse or their parts management system or their quality system or engineering test bench validation system. Being able to cascade this data to all the other systems was something which was very useful. And to mash it up with your cautions data, you are able to now tune your model. One thing fortunate here was this was an operational system, so we already had cautions data. We already had history of these were all the problems which happened with this equipment when it had this performance. So, and this has been running for several months now. So we have an advantage of taking the cautions data mashup to improve the accuracy of the model in the two cases which I was talking about. That's pretty much about it, and I have probably a few more minutes to take questions.
Yeah, so